So throughout this video, I'll be explaining about everything I have done in my MLOPS pipeline from top to bottom, and also giving a good relevance of what I've entered in the report too. So starting from the first about this pipeline, the first stage was to choose the data set for starting this pipeline, right? So I choose three data sets, one from one is phishing data set that was from cybersecurity domain, and the other two was from healthcare domain. One was dry eye, this is a ER diagram, another was thyroid risk classification data set, and another was phishing URL data set. Among these three, I choose phishing URL dataset, which was a flat CSV dataset, because it was collected from different sources, legitimate URLs from one, and phishing URLs from one, and it was combined into one CSV, flat CSV file. And it was pretty much clean. So for just loading in the MLS pipeline, pre-processing would not be needed much. So phishing dataset was chosen. So this is the overall pipeline. I'll be explaining through each of the DAG process, and also let's start from data storage. What was the initial plan to store the data storage? So the initial plan for the data storage was from three ways. Two being from the user data sets and the user input data, and one for how to store the data set in the table. So I have used MariaDB for storing this all data. For demonstration, I have opened that. You can see there is a phishing database, and there are three tables. One, user input big table stores all the user inputted values, and the phishing data big table includes the table form injection of the CSV flat CSV dataset of the original dataset that we actually used. So I'll be just saying how the data would be stored. In the data ingestion DAG file, I'll show you the code too. In this exact precise file, the CSV is taken and it is ingested into the table, and the other is user input storage. The model is deployed, the fast API is deployed via two major things. One is locally deployed, another is deployed in a render hosted in the cloud. You can see I have deployed here. The GitHub repo is actually deployed. I'll exactly explain how it will work. And if users enters any URL in this, that will be stored. And that how it will be stored is there is a download URLs endpoint in the fast API, and the download URLs has all the URL inputted by the user. And when a tag runs, the exact model development, deployment tag task, this exact function will fetch that URL and extract all the URLs, and one by one it will insert into the table. I'll exactly explain in the deployment stage how it will work. For now, I have explained the strategy, and here in the database of single big table is used. The schema of star schema is not used because star schema, while being efficient, is not necessary for the small data database, and also the duplicate data will not occur here. So the best match would be the single big table for the easy access and also for the easy understanding of the ingestion of the data. Now looking at this, let's start the DAG process. I'll explain one by one. Let's start the DAG process. So in my DAG file, which this is the ones I have used the one single DAG file. This starts with several batch operator here for starting all the services, Docker setup, and also starting a Redis server. I have used batch operators. You can exactly see these are being running. So these are all automated. Users need to start Airflow. Users need to start Airflow scheduler and Airflow web server, and only the DAG needs to be run. And the DAG is also scheduled for every 24 hours. Every service is there, and just after that, there is a phishing big table schema generation, which just generates a table in that database. In this phishing database, it just generates this schema. It doesn't input any data, and the validation. There is a validation code. Exactly, this is the base which validates the dataset. The dataset in the CSV form is validated here. there is a string generated, and there is written some rule like this level volume should be in which range and how many length should a cooling be. If everything is satisfied, then it goes success, and data are validated, and it moves to data ingestion, and the data is injected. Similarly, after data injection, data pre-processing happens. Pre-processing happens, and as I have said, there is not much pre-processing needed. Just if there is empty data, empty row, it will be removed. And even after pre-processing, there is another validation to check if any error occurs in the data structure. And after that, the model training and model evaluation is there. I would like to remind you that in each DAG stage, like from data ingestion to data pre-processing, there is a Redis used. Redis is used as an intermediate storage. I'll exactly show where the code is used to insert into Redis. This code inserts into the Redis, and this can be pulled in pre-processing from the Redis server. No local, the data are not being fetched locally, it is fetched from the Redis itself. You can see here, it is being fetched from a Redis, and again the preprocess is saved into Redis. Likewise, the data is transferred between DAGs, and Redis is used as an intermediate storage. In the model training and model evaluation, which is basically the model development, in model training, Axioms model is defined, and parallel to that, ML flow, ML, every model what is trained is saved in ML flow, and also the matrices that runs as output is also stored in the ML flow. Even the model is registered and it is versioned so that the fast API could pick the latest model. And just after the model evaluation, this is model deployment. This is the big and important chunk of code. I'll exactly show. In the model deployment, what it does is it fetches the latest model that was trained, latest version model from the ML flow. And as I have said, there is a GitHub repo. I've said a GitHub repo where it has fast API code or index.html for the interface, and a model that will be used for making the prediction. And this repository is hosted in Redder. This is all automated. I'll exactly show. This GitHub is, and in exactly this model deployment, what it does is it fetches a latest model, and it also fetches the model.pkl from the GitHub repository, and it compares the both model. If it is changed, then the new model from MLflow is committed. ML flow is committed into the GitHub, and then this file will be committed and it will be changed. And as it will be committed, the committed will be detected by render itself, and again it will be redeployed in the same URL. It will take just a few seconds to redeploy, and this will use a new model that came from a new iteration of the DAG from the ML flow. That it occurs like that. So that's the model deployment, and model deployment. And just after model deployment, the monitoring task is handled as a DAG task. It is because in every 24-hour monitoring would be carried out rather than manual, because every DAG run schedule in a production level there will be many input that will be stored, and every time model this two tasks, data drift and concept drift. Data drift and concept drift will generate a report for them to analyze whether the model is performing well or not. Any data drift detection is detected or not. If it is detected, it sends an email to. And I'll exactly show the reports of validation also. I have not shown that. The reports of validation, the reports of concept drift, data drift, all of those. And here you can see a whole success iteration of DAG is done. Now I will show how the user input will be stored as I have said here. Let's see the current number of rows in user imported big table. There are 35. Let's go here and give a URL. Let's say we give this. If this already, sorry, this is not valid, so yeah, it's phishing, of course, it's not a valid URL. Let's go with this, copy. Let's take this. This is a legitimate URL. Let's go with demo of a phishing, okay? Facing YouTube, it will be just icon for .com secure. Let's check the URL. It uses a scoring model and says either it is phishing or a legitimate URLs. Now let's see. Now how the data will be stored is I have tell you in here the main.py is the fast API code. It has a download URL endpoint where this URL will be stored. Now when another DAG runs, what I will show is when another DAG runs the model deployment code here. This exact function fetches the URLs in another diagram, fetches the URLs, the endpoint of the render of the fast API that was handled on render, and it will download all the URLs. It will fetch all the URLs, and one by one, it will store in this. It will store them in this. I will exactly show the rows will be increased in this. I'll show it. Let's see the diagram for now. This model deployment stage exactly fetches the download URLs from the hosted ones, and all the user inputted URLs will be saved in the local MariaDB that we have been using. Let's wait for this, and I'll be showing you all the reports that would be generated, that was generated in this iteration, like validations report, right? Exact that. The report that was generated from Great Expectation also that. So as I have said, there were two validation codes, right? For one before the injection of the data and the post-process phishing data validation. So you can see here every Great Expectation code that has been run, it says zero unexpected, so it's valid. You can see the report here for the both validations, and similarly, there is we can also see for the monitoring parts in the reports folder. There are concept drift and data drift. These both report will be generated in each diagram so that uh, we will be aware of the recent data was updated and about the recent data drift schemes here. Let's see data drift. In this code, what it does is it takes thousands of the samples data. So it will take thousands of sample data from a reference and current data. Reference dataset being the original dataset we use, and the current dataset is the CSV form of the table of the user inputted URLs. So it compares that and says whether the data drift exists or not. You can see here the dots are in a single line, so there is no data drift. Similarly, for the concept drift, it does the same. It takes a thousand sample rows from the both user end and also the original dataset, and it generates the concept drift. And the monitoring task can also be done through MLFlow itself. Here are the experiments. Here are the experiments that done. Here are the models that has been registered, 70 version. And you can compare each model. You can compare the output of this model, everything from here. And all the drift report can be seen from the evidently AI that was being used. Now let's go to DAG. Yes, everything has been successful. Now let's see the rules again. You can exactly say the two has been increased, two URLs has been increased, and likewise it stores the user data from render cloud hosted model fast API 2 in a local MariaDB. Thank you. This is the exactly whole pipeline. It integrates all the necessary tools, Redis as an integrated storage and also used as for the caching purpose, and MLflow for the logging of the matrices and artifacts, and also use Great Expectation for the validation, Evidently AI for the monitoring part. And I have already told the monitoring part is run as a DAG task because it is more efficient as the DAG will be running each 24 hour. Monitoring will be automated in each every 24 hour.